The particle model of matter and dissolving rates. So types of solutes and solvents. The most common solvent is water. Water is sometimes referred to as the universal solvent because it can dissolve so many different substances. If you see the term aqueous solution, this means that the solvent is water. It is important to remember that solutions do not have to be made up of only liquids. For example, in this case, we can have a gas solute in a gas solvent. For example, oxygen. Oxygen and other gases in the air, like nitrogen. So it could also be a gas in a liquid. For example, soda water. We have carbon dioxide in the water. You could have a liquid in a liquid, like antifreeze, which is ethylene glycol in water. We could have a liquid in a solid. For example, rubber cement is benzene in rubber. We could have a solid in a liquid, like seawater. Salt and other substances are in the water. Or we could have two solids mixed together, like brass, which is zinc and copper. So solubility changes with temperature. For most common solid or liquid substances, the solubility increases as the temperature of the solvent increases. For example, at 25 degrees, you can dissolve 36.2 grams of salt in 100 milliliters of water. But at 100 degrees, you can dissolve 39.2 grams. The reverse is also true for a gas. As the temperature increases, the solubility of a gas in a liquid solvent decreases. This is why air comes out of a pot of boiling water. The decrease in the solubility of a gas can have serious effects on the environment. Many industrial plants use water as a coolant in their processes. Usually the water is drawn from a lake or a river, and once the water is used, it is warmer than before it was taken. Before it can be returned to a lake or a river, it must be stored in a cooling pond. If the water is returned before being cooled down, then it is called thermal pollution. Since all water contains various amounts of different gases, and the solubility of these gases decrease as the temperature of the liquid increases, then we can have serious effects. As the temperature of water increases, the oxygen gas contained in that water leaves due to the decrease in solubility. Because oxygen is so important to life, many organisms die due to thermal pollution. So factors affecting the rate of dissolving. We have temperature. So increasing temperature makes the particles move faster. Heat energy is transferred by the movement of particles. Because the solvent particles are moving faster, they bumped into the solute particles faster. We could have the size of the particles. So small pieces of solute dissolve more quickly than large pieces. All the smaller pieces together have more surface area among them than the solvent particles, or for the solvent particles to bump into. Think of cooking a potato in water. If you put in a whole potato, it takes a longer time to cook. But if you cut the potato up into smaller pieces, the cooking time becomes much shorter. And then stirring. Stirring moves all the particles around, so the solvent particles bump into the solute particles more often. Thanks for watching.